Good morning, everyone, and good afternoon to my friends on the East Coast. My name is Claudine Fair. I am chair of the AIAA Diversity Working Group, and it is my pleasure to welcome you all to today's panel. Today's panel is brought to you as a collaborative effort between AIAA, the National Society of Black Engineers Aerospace Special Interest Group, and Tuskegee University. Some of my favorite aerospace engineering friends all attended Tuskegee University, so I know you're in for a treat today. I would like to welcome Dr. Khan, who is a professor as well as the Aerospace Engineering Department Chair at Tuskegee University, to share some of the great things about Tuskegee University's Aerospace Engineering program.
Thank you, Claudine, for the introduction, and I would like to express my thanks to the AIAA and especially to the Diversity Working Group and the NSB Aerospace SIG for giving us the opportunity as part of the Black History Month activities to talk about the Aerospace Engineering program at Tuskegee University, which many of you may be knowing. It has the distinction of being the only accredited aerospace program as an HBCU. That's a fact that we take great pride in, as it is right in the true vein of the trailblazing legendary Tuskegee Airmen. Every year we graduate the largest number of African-American aerospace engineers. Thus, we have a pivotal role as far as diversifying the aerospace engineering workforce is concerned. The Aerospace Engineering Department provides an academic environment with learning experiences that prepare our graduates to be successful engineers and leaders, as is evidenced by today's panel of our distinguished alumni. While the panel discussion will bring out several unique aspects of the Aerospace Engineering program at Tuskegee University, and how our students and our alumni feel prepared for their job as engineers and leaders, I would like to mention a couple. The one that we take pride in, and we've been doing it for a while, is our multi-university capstone design, build, fly activity. This activity, to my knowledge, is the longest running multi-university design, build, fly collaborative program. It's now almost a decade old. It provides our students to work in a distributed virtual design workspace, which I think everyone agrees is the future, as well as they learn about distributed manufacturing and integration. They experience real-life teamwork because they are working across time zones and diverse backgrounds with students from other universities. So each team, is made up of students from multiple universities. So it's in a true sense a microcosm of what teams look like in today's professional engineering environments. We have also recently introduced a model-based systems engineering experience with industry support that includes, mentoring by industry practitioners. And in the past, our students have participated in opportunities such as the NASA microgravity program and the university students launch initiative, etc., which still is going on. And of course, our faculty is involved in cutting-edge research, whether it is experimental aerodynamics in volumetric particle image velocimetry, or is it computational fluid dynamics, or small satellites, CubeSats, and controls. Our faculty is involved in all kinds of research, and of course, our undergraduates, are part of this research endeavors and activities. So you'll hear probably more about it from our panelists. But now I'd like to introduce the moderator of today's panel, Mr. Ken Garrett. Ken is the director of the Model-Based Systems Engineering Functional Organization within the Engineering and Technology Department of Lockheed Martin at Fort Worth, Texas. His team is made up of a large number of engineers, I suppose about more than 500 across the aeronautics locations of Marietta, Palmdale, and Fort Worth. Previously, Ken was the director of the F-35 Joint Reprogramming Enterprise within the F-35 PMO. Ken has held positions of increasing in responsibility, including leading the flight sciences test operations at Edwards during the F-35 development and demonstration phase of the program. We're always proud of our graduates, and Ken is one of our graduates. He received his bachelor's degree in aerospace engineering from Tuskegee University and a master's degree in aerospace engineering from the Pennsylvania State University, Penn State. He's a graduate of the Lockheed Martin Program Management Development Program, Excellence Through Development and Growth Enhancement Program, and the Engineering Leadership Development Program. Ken, over to you. Thank you.
Thank you, Dr. Khan, and thank you, Claudine, for this event. This is one of the most exciting things I've done here. Very passionate about the Tuskegee University engineering department. So passionate that my oldest child is there right now. So she'll be graduating in May, and I'll be sending another one. So when my son graduates, he'll be heading to Tuskegee. So I believe in what Tuskegee's doing, and I'm very excited to share with you all the panelists here. I want to just jump right into the panelists that we have are all aerospace engineering graduates. I was fortunate enough to go to school with a few of them, and I have some nuggets on them, but let me start with Hakeem. Hakeem Balgun is a graduate student right now. So after he graduated from Tuskegee, he worked at NavAir in Jacksonville, Florida as an aerospace structures engineer supporting the F-18, F-16, and F-5 programs. In 2022, he returned to Tuskegee to pursue a master's degree in mechanical engineering. Currently, his research is focused on experimentally investigating the flow field of delta wings with thrust vectoring configurations at high angles of attack using volumetric particle image velocimetry, easy for you to say. So welcome to you, Hakeem. All right, Nolita Lewis, after she completed her degree at Tuskegee, Nolita completed a Master's of Science in Mechanical Engineering from the University of Cincinnati. She joined GE Aerospace in 2003 and has held roles in design, repair, systems, and tests supporting multiple MPI and certification programs, including the LEAP-1B, which is the Boeing 737 MAX, and the GE9X, which is the 777X. And then Nolita is currently the executive leader of the Materials, Behavior, and Operations Department in Engineering Material Systems. And Nolita, congratulations. It sounds like you just celebrated 20 years with GE. So congratulations on that. And I just learned while she was killing it in school in Tuskegee, Nolita was also in the band. So a band passion there. So yes. Good to learn that about you, Nolita.
Thank you.
All right. Next is Dr. Sheree Meredith. And I have to tell you, when I was at Tuskegee, Sheree was the smartest person I knew. And to this day, she's still the smartest person I know, but what she can do is she can talk to you about the deep details of aerodynamics and aeroacoustics, but she can also just talk to you about what's down. So I've always appreciated that about Sheree. But after completing her degree, while she was working in industry, Sheree went and received her PhD in aerospace engineering from Penn State. And currently she's now a senior research engineer in the Advanced Concepts Laboratory at Georgia Tech Research Institute. And in her 17-year career, she served as a aviation for the Boeing Company in Seattle, an aerospace engineer on both the environmental control systems and dynamics teams of the Global Hawk program at Northrop Grumman, and as a staff research scientist in signature management within Lockheed Martin Skunk Works in Marietta, Georgia. So the majority of her career focused on contributing and overseeing a variety of research and development projects focused on EO, IR, RF, and acoustic reduction suppression technology solutions tailored for aircraft design. In her current position, Dr. Meredith serves as a chief scientist of the Advanced Warfighting Technologies Division. She also serves as a project director or lead analyst on multiple efforts concentrated on unmanned air system, flight dynamics, signature management, and wargaming. She's a lifetime member of AIAA and current member of the Acoustical Society of America. So welcome to you, Sheree. All right, now we have Mayard Williams. So Mayard's working at Collins, but I have to tell you this. I was always a big fan of Mayard's because not only did he do aerospace, but he was also on the football team. And so he was a receiver, great receiver. So I've always respected him to be able to juggle both of those. So Mayard, I'm a fan. So after getting his degree from aerospace engineering, Mayard also got his master's degree in aero from Tuskegee University, but then also went to the University of Florida to get his master's in business administration. Currently, he works at Collins Aerospace in the powers and controls team, and he is the chief engineer for digital controls and safety, for digital controls, and he's a safety board member. He's also worked in SimCom International, as a flight test and aerodynamic engineer. He worked with Lockheed in the high altitude airship as a lead controls engineer, and he worked with CDI Engineering as the director of engineering. So I've always thought of Mayard as the most interesting man in the world because his outside interests, he also very big on family, but he has his private pilot's license, and he's a ground instructor also. Scuba, plays golf, basketball, football, baseball, college, and also he's a college and high school football official. So Mayard, welcome to you also. Welcome to the most interesting man in the world. All right. So question number one, and so I'll start, and Hakeem, if you could start us off with this one. How well did the aerospace engineering program at Tuskegee University prepare you for your career and technically and professionally?
Hey, everyone. So I graduated in 2015 and I joined NAVAIR as an aerospace structures engineer. Before I joined NAVAIR at Tuskegee, I was involved in the USLI program and I did the design, build, fly program. So I was able to get some hands-on experience with the various components of aerospace structures, whether that's composites, whether you're talking about metal structures. I was involved with designing like some of the airfoils on our design, build, fly program and some of the VTAL designs. And even with my structures courses, I got a pretty good foundational understanding of like load paths, shear stresses, like all the things that you learn today in your structures classes. Like we actually did that on the job. So I wasn't really hit by anything that was too out of the water. So I think that was very good because I got that foundation. And while I was on the job, I had to do things like develop structural repairs for battle-induced damage on the F-16s, the F-5s, the F-18s. So these are pretty mission critical items. We did structural repairs and we calculated fatigue life. We looked at single load path structures. We modified flight critical parts, category 1 parts that could cause catastrophic failure of aircraft. So this is stuff that really affects the pilot's lives. So, you know, I think Tuskegee pretty much gave me the foundation in order to succeed in my career. And it also gave me the ability to always want to learn more, and that ability to know how to learn more. And I think that's very important.
Thank you, Hakeem. Nolita?
Yep. So again, thanks for having me. And Ken, thank you for the awesome introduction. So my path, you know, after leaving Tuskegee, I went on to work full-time and joined a program that GE had at the time called the Edison Engineering Development Program, really technical program for 3 years where I had the opportunity to get my master's in engineering. So Tuskegee prepared me from a professional standpoint just exposure to career fairs and internships. I remember sitting in Dr. Khan's office going, you know, what am I going to do this summer? And he challenged me to think about, you know, an internship. And so from that point on, and every summer following, I had internships in engineering, in aerospace. So, you know, working alongside him in the career placement office at the time run by Sarah Stringer, with just how you conduct yourselves in a corporate environment, like always representing the university, you show up, you participate, you articulate all the most important things that, you know, you may not necessarily hear or learn, you know, in the classroom. I'm very thankful for that as well. Now, from a technical standpoint, I would say the method of teaching that we have at Tuskegee was very collaborative, very team focused, and a bit more hands-on than maybe some of the other universities that I've learned after kind of, you know, being in or at GE long term. And so working with that master's program and some students who went to some of the other big engineering schools definitely had an appreciation for the method in the way that we were taught at Tuskegee. So really helped me prepare for corporate America in my career in aerospace.
Excellent. Thank you, Nolita. I agree with you that collaborative teaching was really important to me also at Tuskegee. Dr. Meredith.
All right, so hello everyone. Thank you, Ken, for the intro. When it came to me, I would say that Tuskegee allowed me to have a very solid foundation in aerospace, understanding the fundamentals in an environment that was very welcoming. I could go and talk to my professors about anything, but not only that, they helped charter my career. It was one of my professors who actually told me that I was good enough to go to graduate school and to get a PhD. He planted that seed in my mind. And from there, he made sure that I had opportunities to do summer research programs at MIT so that I could get the experience of what it was like to do graduate work. But thereafter, I also spent summers at Boeing as a flight test engineer, getting the industry experience as well. So having the opportunity to have that, as well as the ability to even call back my professors and be able to talk to them, even as I progressed in my career, when it came to the next school that I went to, just being able to touch base with them, it allowed me to have that continued support that maybe I would not have had elsewhere.
Absolutely. Thank you for that, Dr. Meredith. I share that also. I called Dr. Ali, Dr. Shepard all many times. So thank you very much. Mayard, same question.
Same question. Thank you. Thank you, Ken, and thank you, everyone. So Tuskegee is now for, you know, producing solid engineers, and that's going before even I got there. But one thing I would like to say specifically for the aerospace group and the aerospace department is that we were taught the fundamentals at first, you know, the theory, classical analysis, doing the derivation. And what that taught us was how to dissect larger problems down to smaller components. And then we also had lab projects. We had the flight vehicle design lab. We had trips to molten field. We had simulators. We had the wind tunnel, all those different instruments that we had to learn with. We thought they were above cutting edge in some areas, and we thought they were subpar in some areas. But we used what we had, and when they broke down, guess who fixed it? The students fixed it. So we got that practical skills embedded earlier on. Now, professionally, I would say there was no freebie. I think everybody could take their head direction and agree that when you saw red ink on your paper, it wasn't blood, it was your answer was wrong. And you got to go back and learn and get some help and get the professors to stay longer and ask, and they stood longer, and you were able to ask questions. And so that gave us the opportunity that, hey, look, my answer may not be right the first time, but it gave me the confidence to ask the questions, go get help as you work into the industry. Never afraid to ask, always taking risks, solid risks, conservative risks, and making sure your designs are layered correctly.
teamwork, late nights in the flight vehicle design lab. I mean, we can go on and on and on. Everybody put their work in. Everybody stayed late. Everybody helped each other out. It brought a sense of work ethic. It instilled that DNA in us early so that when you're on your projects at work, we're raising our hands. We're staying behind. I mean, it's just part of the culture that was ingrained in us at Tuskegee, is that we don't want to stop until it's done. And we get notice from that. And it's very, very popular and very positive, but it's just what we're known to do. So that's my take on professionally and technically.
Oh, absolutely, Mayor. You know, I remember professors, either Dr. Bofa or Dr. Harris, coming in with a marker and starting at the top of the chalkboard and just going all the way through and going to the end and deriving an equation. And
yeah,
I'm sitting there, it's 30 minutes later. It's like, we could have just started with the end right there. Just give me the answer and then we could plug the numbers in. But no, they wanted to make sure we understood how that equation was fully derived. So yeah, I remember those times. All right, so let's move a little bit into some specific career challenges. And we have two African-American females here who have done great in their industry. So Sheree and Nolita, please share your career journey and challenges as an African-American female engineer. And so I'll start with you, Nolita. What are your thoughts there?
So I think my journey was unique. I didn't, like many, come out knowing exactly what I wanted to do here at GE. I knew I took a propulsion class in undergrad, and it piqued my interest enough to where I wanted to go and work for GE and see what it was all about. One of the things that was instrumental in my development and helping me find my way was, finding a technical mentor early. Not a mentor, but a technical mentor early. The second thing that I tried to do was focus really on what I wanted to do, what kind of job that, was available to me where I would be satisfied and I would be excited to come here every day and do it. And then and the last thing was around, finding my passion in those areas, right? So if you look back at, what I've done, I've worked in design, I've worked in test, I've worked in repair, worked in systems, and now I'm leading a material science organization and I don't have a materials degree. And so some of the challenges that I faced as an African-American female engineer, I'm a first generation college student, first generation corporate America. And so one of the things that I often struggled with was being accepted and, in true transparency, feeling like I'm good enough, right? I know I came from this prestigious university. I know I have the training from some of the best professors out there, like being accepted and being good enough. Quite frankly, a lot of times, 95% of the time, I'm the only person in the room that looks like me, from a African-American standpoint and also from a gender standpoint. And so it was being accepted and proving that I could compete with my peers at every level. And I think I've overcome those challenges. And so some of the things that I try to do is to really build into the ones that come after me and making sure that if they are struggling with those things that, I can provide some guidance and insight.
Excellent. Just one other point to it, and while you're speaking, Nolita, as far as recommendations to encourage and motivate females towards engineering careers and retaining them, what are some of your thoughts there? And Sheree, I'm gonna ask you to answer both of those questions also. Go ahead, Nolita.
I would say really quickly, the world is changing, right? Companies are recognizing the value of having women leaders in their boardrooms, in their technical discussions, and every place else. So don't let anything cause you to give up on your dream or being a good engineer. Find a mentor, find your tribe, and do, and incorporate all the things that you learned at Tuskegee. So the hard work, as Maynard spoke about, he was my TA, by the way, when I was there, but the hard work that Maynard spoke about, the collaboration, the diversity of thought, we were taught differently. And so it's okay to go into a room and completely throw a curveball because your peers haven't thought about it. It's very rewarding. And so I would say, don't dim your light, but to attack, the industry head on and be the very best aerospace engineer that you can be.
Great recommendations. Dr. Meredith.
Okay, so to answer your first question, I would say one of the main challenges I have faced is being a statistic. As a Black female, you serve as what I learned, a twofer, where you check off 2 boxes in the minority category. And a lot of times it's easy to get relegated to that and get sidelined in the sense that you are not recognized for your talent and capability. But I will admit that going back to Tuskegee, my fellow aerospace brothers definitely gave me some pretty thick skin to be able to push beyond and challenge that which I came across. And so being able to showcase my talent definitely allowed others to recognize my capability and allowed me to excel within my career. In terms of advice that I would give, I would echo Lita in the sense that it is important for you to find a mentor. And in my case, I would say that I have mentors that don't look anything like me, but they have been phenomenal. There are individuals who you would least expect to be in your corner, but yet they are there and they will help you throughout the process. And so that would be a major, major thing that I would encourage.
Oh, that's great advice. And just to tie together what both of y'all said, that mentorship is key, but also your performance, you being the best you could be so that people can see what you're doing and say, yeah, I don't care what you look like, I want to grab a hold to that. So that's key. No, that's excellent advice. Thank you both for that. All right. So I know, going into industry, once you start going in, making money, it's hard to get out. And I know when we have the perspective of, you may like school, you may like doing may like doing something technical, but once you start going down the path in the career to come back, it's pretty amazing. So Hakeem, yeah, we want to talk to you about what was your motivation to come back and pursue graduate studies after you started a full-time job?
Oh boy. So this is a very interesting story. So this is all off the back of the pandemic in 2020. As everyone knows, there was a lot changing in the world, working from home. You kind of have more time to kind of think about where you want to take your life. And then at that point, I had realized that I spent five something odd years as a structures engineer. I liked my job. I got to work on really critical missions that, one, help the country, two, you can actually see what you work on. Like, the airplanes that I worked on actually flew. Like, once we were done with the maintenance, they would fly like the next day. So I think at that point, after about 5 or so years, I reached a point where I thought I had mastered enough of the structural engineering concepts that I wanted to diversify my abilities. So aerodynamics is like my first love. So structures was something I stuck with as my first job. So during the pandemic, I just decided why not go to graduate school to get a specialty in aerodynamics. And during the time, I was speaking to one of my colleagues who was also in the graduate program. And I heard about the research he was doing. And I thought, wow, this is exactly what would allow me to kind of diversify my abilities away from structures and combine it with aerodynamics. So, right now I have a pretty good grasp of aerodynamics and structures, and I can kind of think about them as like coupled phenomena. If you think of something like aerodynamic flutter, like that's an aerodynamic problem, but it's also a structural problem from the perspective of fatigue and even static strength. So, with that in the back of my head, I contacted Dr. Khan. I let him know where I was, what I thought, and he said, "Well, I mean, I am looking for a research student." So he told me to apply. I applied and got in, and ever since then, I've been at the department doing this aerodynamics research, experimental aerodynamics research, and it's been very fulfilling, very challenging, very novel, not too much information on what I'm doing So a lot of the things I'm doing, I'm kind of like on the cutting edge, and I'm creating new processes for even manufacturing my models that I'm doing for testing. So that's kind of the backdrop of me coming back.
Hakeem, I really appreciate how you've looked at your career as a complete journey, and you haven't just focused on one thing, and you see how each of these pieces of the toolkit can add to your value as future goes on. So I respect that a lot. So bringing in the aero side, that's really deep. So thank you for that. All right, so I'm gonna jump into another specialty here. I'm jumping around, Claudine, don't get me. But I'd like to talk a little bit about propulsion. And so I know it's one of the things we studied at Tuskegee there. And I'd like to ask about the propulsive engineering horizon, like what's coming and what's happening. What are some of the things we should be looking at? And are the current aerospace engineering programs well poised to educate and train engineers to tackle the challenges that we're going to be seeing in propulsion technologies going in the future here? And I'm gonna start with Mayard here. If you could start us off on that one, Mayard. What are your thoughts there?
Hey, sure, no problem. Propulsion, where are we going in years now and beyond? And I think at Tuskegee we had a engine, a working engine, a turboshaft engine in the engine laboratory. Dr. Harris was instrumental in supporting that package, and Dr. Shepard. And we were able to get hands-on work on the engine. Only problem with that was that we could only run the engine on Friday afternoon when everybody was on the yard partying. So here we are, aerospace students down in the lab running this engine, making all this noise. But we were studying the next generation. We were studying specific fuel consumption. We were studying how thermals was reacting to different environments and how you change various settings. So where are we going right now? And from a Collins perspective, and we have some lofty goals overall to reduce carbon emissions by like 2050. And by that, we're talking about how do we make our engines lighter? How do we make the carbon footprint much less aggressive than it is today? If you look at 2050, that's 30 years from now. That's still within some of our lifetimes on the panel right now, and some of that's on the call that we're going to be part of. We're going to be part of that activity. And I feel that, we're looking a lot to see how systems come together. Systems come together because it's interacting together, right? You have the propulsion unit, you have the aircraft, you have whatever vehicle you're using to stabilize it. That's a whole system setup. And understanding what Tuskegee was doing in terms of preparing us to be systems engineers, if we don't have a degree in systems engineer, but it's how do you combine all the different courses and different classes, and now you become this unique systems engineer. Control design. And I want to end up on one particular area that is unique to me, particularly, that is advancing cybersecurity. Cybersecurity is probably one of the most common thought of activities, but it's very, very complex. And we're introducing cybersecurity into our engine-based models and to our digital controls. And that effort right now is cutting-edge technology. We need our students to continue to learn how to understand the systems, understand software coding, those kind of things that we know Tuskegee is built upon, and that will help us advance that industry much more better into the future.
Yeah, no, cyber is a big piece right now. So you're absolutely right there, Mayor. Thank you. Nolita, what are your thoughts there?
So agreeing with everything that Mayor said, if I look at some of the things that we're working on here at GE Aerospace, right, we're working on a groundbreaking fighter engine, the XA100, right? It is the first and only adaptive cycle engine. And for those that don't know what that means, it's a jet engine that is designed to operate efficiently under mixed flight conditions, such as subsonic, transonic, and supersonic. So it's going to replace the F-35. I know you worked on that, Ken. I heard that in your intro. But it's going to replace that. It's going to deliver 30% more range, right? We're working on how do we get double-digit fuel burn out of our engine? So a lot of big things, a lot of cutting-edge technology. And I think it's important, as we think about the university and how our program stays relevant, it's making sure that we are doing exactly or continuing to do exactly what Mayard mentioned and having those partnerships with the corporations. I know there are tons of opportunities out there for just GE Aerospace where students can work on a real world problem that we have in the industry, right? So how do we make those connections? Participating in, programs. Right now, GE just kicked off an Explore Engineering program that offers current university students insights about the work that we do at GE Aerospace through or by creating or completing real world samples. So they get a real world problem. It's a two to 3 hour, exercise at their own pace, but it gives you a feel for what it's like to be an engineer here at GE. So I think it's making all those connections, understanding where we're going, making all of those connections, and really making sure that our students leave as prepared as those of us who are currently in industry left.
No, that's really good. And what both of y'all highlighted too is something that, when I was coming out, and Sheree talked about this just as far as mentoring goes also, is there are these trends that are happening in the industry. And if you can ride the wave of a trend and get right ahead of it and be successful in doing that, then that really sets you up well for your career, but it also sets you up well to impact technology going forward. So thank you both for those nuggets on propulsion. Doing a time check here. So I want to make sure we get to a couple of questions and we have time for the audience questions too. So you all please be conscious of your answers here. But Tuskegee has a 40-year track record of developing world-class aerospace engineers. So for you all on the panel, what are some techniques that you experienced at Tuskegee that you believe the aerospace industry can utilize to develop a workforce that is more reflective of the diverse population of the United States? And I'll start this one with Hakeem. What are your thoughts here?
Yeah, so I think that's an interesting question, especially off the backs of everything that's been happening the past couple of years with these diversity, equity, and inclusion programs at companies. I think one of the biggest things is outreach from companies to Tuskegee and even HBCUs more broadly, but specifically, I think educational partnerships where companies are providing research opportunities, research dollars, and even equipment to the university in terms of, and I think with stuff like that, one, it shows a commitment from the companies beyond just basic diversity, equity, and inclusion programs. It's something tangible, right? And I think that helps, especially with like community outreach. I've noticed at Tuskegee, Dr. Khan has been pretty big on going to the various elementary schools and middle schools and, building flight simulators. When I first got here in like 2020, we built a couple flight simulators and we put them at BTW and a couple schools in Montgomery. And when we're setting these things up, the little kids are asking, oh, what is this? Like, what are you doing? Like, what do you do for a living? And then I would explain and they would seem so enthusiastic about it. So I think those types of things can really help to bolster diversity in the workforce, because it's really just, I think a lot of people are interested in this type of stuff, but it seems kind of overwhelming. So I think kind of bringing it down to everyone's level and just letting people know that there are these opportunities, and companies themselves being more intentional about what type of opportunities they want to give. And I think that would really help.
That's good. Dr. Meredith?
I would say have a vested interest in the community. And I take that from the perspective of the way our professors were with us at Tuskegee. I mean, there was concern to ensure that we learned, that we understood, but also being able to apply. And what I notice is when it comes to diversity, everybody has a different perspective, and it's one in which we can feed off one another and increase the capability, because we're all going to see things from a different perspective or a different angle, and that contribution strengthens and bolsters the technology and the capability of whatever it is we are trying to build or to succeed in. And I would say that coming from the perspective of having to deal a lot with the military and having to support them a lot in aerospace, I think that it serves as a reflection of what it is we need to do in the sense that we are all in this together. I mean, current events, things that we're seeing, and maybe even some of the things that we're not seeing, we have to work together.
Absolutely. Nolita?
Yep, and I'll be quick. So 3 things for me is appreciating the diversity of thought. As Dr. Sheree mentioned, you know, Tuskegee ingrained that in us. I was just telling the panel earlier today about that. Collaboration at all levels. So, you know, this whole top-down approach that a lot of companies have had, I think the collaboration, the not being afraid to tell the news, good or bad. And then also, you know, lastly, not being afraid to do something different, right? Or try something different. So again, going into a room of your colleagues that are trying to solve a technical problem and offering a different perspective and not being afraid to do that.
Absolutely. Thank you, Nolita. Mayor.
Okay, I think I could be quicker. So just, I'm echoing everything what we all said is about the investment in our universities with research and development programs, the collaborations at the industry level, and the co-op and internships. They have to invest in the Tuskegees and the North Carolina A&Ts that have strong engineering programs. And that way it fosters that growth and it fosters that pipeline. When we stifle it and industry goes only to one particular type of school, it eliminates the opportunities for schools like HBCU to get involved. So I think as long as we continue to progress and continue to show that once you get us in the door, we're going to show up and show out, I think it's very positive, and it always has been. I'm fortunate enough right now to be in a recruiting role as well at Collins. And these are the discussions that we're having right now continually. How do we get involved with HBCUs and recruit through HBCUs and some of the Greek organizations as well? So there's a real conversation that we're having right now, and I'm glad to be part of that team.
I share that passion with you, Mayard, and I think we as a country are seeing the consequence of not allowing African Americans to have the GI Bill and some of the discriminatory practices in which we had a whole group of people that could have been going to school to learn some technical fields, and now we're struggling when it comes to engineers and scientists, and we can't let that happen another 10 years from now. So you're absolutely right, and like you said, Sheree, that motivation to get involved with different perspectives has to be there to be able to fund and support programs to push forward a number of the HBCUs. All right, good points, y'all. So we're coming down here. I got about 7 more minutes. So I want to make sure you all have an opportunity to just talk about, in regards to AIAA and to the AIAA domains of aeronautics, aerospace, R&D, and space, what is the direction the aerospace industry is moving, and what role will you play in this? And so I'll start off with aeronautics. And I'll ask Nolita to give us some points here. Where do you see us playing in this?
So a lot of what I mentioned before, you know, about the fuel burn and the thermal management and, you know, the different types of engines and what their capabilities are. I currently work in the materials behavior space. And so we are working to develop the next generation of engine materials, right? Hotter, more efficient, different environments, and making those technologies such as ceramic matrix composites a reality, right? So bigger engines, you know, just things that we wouldn't, or we dreamed about 20 years from now are becoming reality. And so getting the right minds in those spaces to really make those things come to life.
Nice. Mayor?
Yeah, just real quick on the Raytheon technology platform. We just recently had a flight demonstrator that was a hybrid electric engine, and it reduces the carbon footprint. It improves on fuel efficiency. So that's where AIAA and its interaction with what's next and what's involved in the industry is where we see the connectivity. It's a very path forward, and it's very progressive, and it's technologically strong. So hybrid electric, I think that's a good platform for AIAA in the mix to be involved in.
Okay, thank you. So how about in the R&D space, Dr. Meredith, what are your thoughts?
Okay, so one of the major things that we're seeing is drones, and those being group 1, which are the really small ones, all the way to the group 3 type of drones. And what we're looking at is submitting these as fleets where they would serve as maybe escorts for bombers or other high value platforms. And we're looking at them operating autonomously. The understanding is when you're going out there, you want to be able to confuse the battlefield. But not only that, we have to recognize that it's going to be an integrated battlefield with both manned and unmanned systems. And so just understanding how they can work together is a major, major focus for us. And with regard to, as something that Nolita said earlier, it would be the propulsion systems related to that. How can they sustain and endure for long periods of time in flight, maybe even maneuverability associated with that.
Excellent, thank you, Sheree. Hakeem, how about in the space area?
Yeah, so the space area is really exciting. Large amounts of capital are going into the space industry right now. You see companies like Lockheed, Collins, United Launch Alliance, Northrop, SpaceX, Virgin Galactic. There's so many companies right now who are working on things like getting payloads into space, whether that's satellites. Satellites are a big thing. The world is more interconnected now, and it's not going back. Even with just communications, I've noticed with satellites, they're using them for things like remote sensing, where they're able to map out entire forest biomes through satellites. And that type of information is critical for climate change. They've been using that for historical research. They found giant cities in the Amazon, hundreds and hundreds and hundreds of years old, just through satellite remote sensing. So like a lot of this stuff, like you wouldn't know that this is going on, but this is going on. And they need thousands and thousands of more engineers. And I think this is a great opportunity for Tuskegee University students. I'm reminded of, we have like a giant magnometer in the satellite, the satellite lab where, and Tuskegee, we were doing a lot of CubeSat stuff where I think there was a partnership with the agricultural department to look at how how plants are affected by the low Earth orbit and even higher environment in terms of like radiation, right? So these are the types of things that a lot of students can get into, and space is becoming like the next frontier. It already is, right? And everyone wants to get involved with it. So all companies are getting involved. So I think it's a great path for students to look into.
No, that's great advice, because that is the next thing. We're moving out, and in our lifetime, we've seen a military branch formed focused on space. So the Space Force is a whole military branch. If you don't realize how important that is, that's a huge thing. So thank you for that, Hakeem. And I'll take a shameless plug here on the aeronautics portion also, just to say, one of the questions we were going to talk about is model-based systems engineering. Is it a fad? Is it a thing of today? And I'll just give you a story here. In developing aircraft, and for F-35, F-22, roughly it's around 20 years from the time you start getting contracts developed to when you start completion. It's about 20 years. Imagine the technology that changes in 20 years. So just think about your phone, how quick the phone has changed. Think about storage on computer space. I mean, I think my first computer had it wasn't even a 512 meg drive. I mean, it was small. So think of all those technologies that are constantly changing. So what happens in a model-based environment is you're able to work through the entire life cycle of a program. So things that you do in design, you can see how that affects production. You can see how that affects test and sustainment and all those different areas. And so that is becoming a critical portion of what we're doing going forward. Can't pay for large test programs anymore. And so parametrics are important, and how we simulate data is very critical to how we move forward. So I think model-based systems engineering is something that's here to stay, and something we need to, I'd say that's something else to look into, just as some of these space technologies and propulsion technologies we talked about. That is, the modeling world is something that's very important also. So I want to make sure we have time for questions here. So I do have one question in the chat here. And Monique, I guess I'll just go ahead and read it. When you speak about the ability for students to work in real world problems and labs, are these opportunities open for undergrad, or are they primarily grad school? And who wants to take that?
I'll
You
take
want
that
me-
one.
Okay.
Uh-oh.
Go ahead.
Okay, I'll go first really quickly. So the Explore Engineering program that I mentioned is for undergrad. So I sent the opportunity to Dr. Khan for the Tuskegee students that are currently there, but it doesn't stop there, right? Grad students are also able to participate. I think I think I also mentioned partnership thing with companies to work on real world problems. Like they are financially supporting the university to do this is also something that can be done at the undergrad and grad level.
So I'll add some information from the point of view of what we do in the aerospace engineering program. Certainly, it is for undergraduate students, the collaborative teamwork and the design, build, fly experience. And actually, it's meant to address two very important aspects which Nolita, really very clearly pointed out, that when you go into the workplace, there are two things that you are encountering. First one is your own confidence that you are professionally sound. And this collaborative design built with students from other universities provides you with that confidence that whatever the aerospace engineering program is that you are learning is as good as, or even in cases better than, some of the other universities that you are learning at. So that's the first piece of that success at your workplace, confidence in your professional ability. The second one is, of course, the classical resistance to change that the others are not ready to accept and acknowledge you and give you a place at the table. And on that account, you all are trailblazers, just like the legendary Tuskegee Airmen were. They were trailblazers in their own time, as far as that challenges that the African Americans were facing at that time. The aerospace engineers of today, I consider, our program, as I mentioned in my introduction, is exactly in the same direction as being trailblazers, where people with your competence, people, those who don't like change, are forced to accept that, no, there is no way but to move forward.
Yes. Oh, that's great input, Stos. Thank you for that, Dr. Khan. All right, do we have any other questions in the chat? And actually, yeah, I didn't see any other questions. Oh, here's one. From Joy Spraggins. I am a Tuskegee Airman historian and CEO of the Legacy Bridges STEM Academy, Inc., and interested in collaboration. Well, Joy, we'd love to collaborate with you. And so please, reach out to Dr. Khan or any of us here on the line. You'll find everyone here is passionate about the Tuskegee Airmen's history and also just the university and what that means to all of us. And I just, on one note here, while I have a moment, one of the great things about Tuskegee, it's very rare in that, like I told you, my children go to Tuskegee now, and my wife had a situation where she had an instructor that taught her, and that same instructor taught her daughter, or taught my daughter. And so in the aerospace department, one of our longstanding instructors was Dr. Ali, who recently passed this year, and it felt like losing a family member. And so, yeah, I just wanted to take the moment to say rest in peace, Dr. Ali, and this is the fruit of what his labor was. So we on the panel here all benefit from his teaching, and we appreciate all he did.
There are a couple of other questions, Ken.
All right, you mentioned the growth in space. Is there curriculum focused around aerospace engineering as well?
You want to take that, Ken?
Yes, please.
Yeah, so certainly since we are an aerospace degree program, we have to have a curriculum which includes space. And so we have courses in space as well. Orbital mechanics is one of those courses. We have a design course, which is a technical elective in satellite design. We have advanced orbital mechanics. So yes, the curriculum does cover the space component.
Thank you, Dr. Khan. Oh, we have another distinguished alumni. Yusef Johnson has a question. What continual learning opportunities do you all take advantage of? I'll throw one out. Right now, I'm getting my master's MBA from the University of Tennessee. And so I know that's probably going a bit adjacent from the specific aerospace field, but I was very interested in, I've done engineering and very interested in getting a business background, and I've worked in program management. So that's one with my company that I do take advantage of. But any other panelists, any other continual learning opportunities?
For me, it's learning all aspects of aerospace, right? I mentioned I'm taking or learning the materials behavior space at GE Aerospace. I am not a materials engineer, I have no materials. I think I took one class at Tuskegee around materials, and that was many, many years ago. And so GE is a company such that, you know, you can try different things in different areas, and you don't always have to have every criteria met in order to do the role. And so I have taken on roles that I may not have had the qualifications for, but I can do the job and I can learn the job. And so for me, it's a continual learning process when I take those new roles that I don't necessarily have the experience in. And I learn a lot and continue to grow within the company, but also my aerospace knowledge.
I will say that at GTRI, we actually offer short courses in particular areas. A lot of times when we get into industry, there's a concentrated area that you really aren't exposed to in school, and that's independent of whatever school you go to. And it's usually related to, in my instances, it's been related to signature. So infrared technology, specifically as it pertains to the aircraft, or RF technology, things of that nature. And so those are some of the courses that I have taken in the past to continue my education.
It's a good point, Sheree, that usually when you get into industry, they're specific, very specific to whatever your job will be. So it's a good point. All right, how are students recruited? Dr. Khan would like to, go ahead, Dr. Khan.
Yes, so of course, like any other university, you apply to the admissions office with your application. The process is given on the Tuskegee University website, and you choose your major on the application form. So it's a regular process with your ACT or SAT scores and your high school diploma. Usually, and we do recommend that if you do, AP courses and get at least a 3 on the AP courses, that gives you a heads up as far as the undergraduate program is concerned, because those courses transfer. So if you are in high school right now and you are listening to us, you should be seriously thinking of doing AP courses, which are very helpful towards your college education. But the procedure is given on the Tuskegee University website. But if there are any questions that you want me to answer, feel free to reach out to me. I've put my email in the chat. It's mjkhan@Tuskegee University, or you can find me on the Tuskegee website. and I'll be more than happy to guide you personally through the process of admission.
Hey, Dr. Khan, in case that question was also getting into how corporate recruits, there's a number of companies that come back to Tuskegee just because of the quality of the engineers. There's two major times during the year. There's a fall career fair, and then there's a Tuskegee University Businesses and Engineering Conference that a number of companies come back to recruit talent. And so we have a few more questions. Claudine, I think we're up on time here.
If you're able to, I would love to continue. If not, we can address the questions via email.
Okay, I think, yeah, if we could, while we have the folks here, Dr. Khan, there's a question on aerospace versus aeronautical engineering. Do you mind talking a little bit about that?
Sure. So aeronautical engineering and aerospace engineering, the difference as far as the degree is concerned is that as I mentioned a little while ago, if you have a degree in aerospace engineering, then it also includes, along with aeronautical engineering, it also includes space. So both atmospheric and non-atmospheric engineering aspects are included in the aerospace degree. Whereas in an aeronautical engineering degree, it is limited to only atmospheric flight, and space is not included in that. So we have an aerospace engineering degree. So we talk both about atmospheric flight and exo-atmospheric flights, which is space flight.
I'll never forget those orbital mechanics classes. So,
Yeah.
One other point I want to get to, I am a mechanical engineering major, and I was wondering, without having an aerospace minor, am I still able to get jobs or internships with aerospace? Just curious. Hakeem, you want to take that one?
Yeah, so the interesting thing about that, when I got my job in 2015, I was working with mechanical engineers on the F-18s, F-5s, F-16. So, you know, mechanical engineering is so broad, and I feel like aerospace is like a more specialized mechanical in terms of like what we do. So there is a lot of crossover. I would say if you're interested in aerospace, if you can, definitely take a couple courses so you can get caught up on some of the specifics of aerospace literature. But you really shouldn't have a problem as long as you have relevant technical skills to like the aerospace companies. And, you know, right now, my master's degree is in mechanical engineering, but I'm doing aerospace research with Tuskegee. So I've applied to different schools. Excuse me. I've shown my resume to different employers, aerospace companies. They don't care. They just want to know, can you work on aerospace systems? Do you know the fundamentals of aerospace? And can you adapt and learn new things? So if you can, you'll be fine completely.
I think Nolita gave a great example of that too. And just like you said, Hakeem, after a while, it's all about performance and what you can do. I think when you're in research and development and some of the charade type fields, that's very specific. That's very important. Okay,
Just
do you
add that real quick? A professor told me, what we giving you at Tuskegee is a license to learn, and that's your entry into the door. Period.
I love
Excellent.
that.
That's
And
real good.
Question about mentorship for current students. Are there any mentorship opportunities for current students and alumni?
Yes. Oh, go ahead, Dr. Gus.
Yes, I mean, and all those persons who are on the panel actually are mentors to our undergraduate students, you know. So we have that program for our students where we you know, request our alumni to mentor the undergraduate students, and they're more than willing to mentor whoever, you know, reaches out. We try to match you know, our undergraduate students with those who are interested in getting mentors with our alumni. So yeah, definitely we have that with you know, our alumni who already are working in the industry, and of course on campus with faculty as well. You know, as I mentioned, we have research opportunities for our students, so which also includes mentorship of those students.
I think everyone here is very willing to support. So I'm speaking for the panel now.
No, for all our alumni.
Oh,
I can
yeah,
speak
we
for
got
all
more
the
alumni out there.
Yes.
Yeah, we got a lot that we can support.
They are always
right.
willing to step up. Yes, always willing to step up and do more.
So one of the questions is, do you have anything, i.e. programs for non-degree seeking students?
Currently, we do not have any certificate programs, as they're called, on other campuses. We may have in the future, and we are thinking about it, but right now we do not have.
Okay. And then Evan Daniels, another esteemed graduate of Tuskegee in the Aero department. Does the Aerospace department have an Instagram or any other types of social media outlets?
Yes, the Aerospace department has a Facebook page on which most of our alumni are there. So yeah, please search that. And if you can't find it, send me an email and I will, add you to the Aerospace Engineering Facebook page.
Evan, was that a millennial nudge that we need to get into Instagram or something other than Facebook?
I know. I mean, I personally have
Well
an Instagram,
done.
which I rarely look at, but I will
Well
remember
done.
that, and I will set up an Aerospace Instagram and Twitter account. It will be done
All right.
today. It will be done today.
All right. How is it like to work for Lockheed Martin? What skills I need to work on during college phase, like stuff I work on with myself? That's a great question. So I know Sheree has some experience. Mayard has some experience. Lockheed, y'all want to talk a little bit? Because I'll talk a lot. Or Claudine?
Sure. Well, I'd be happy to. I work for Ken, and this is fully unbiased, but I love working at Lockheed Martin. There's so many different opportunities. I started out at Sikorsky, and now I'm currently working at Skunk Works. The culture is great. We work 4 days a week, 10-hour days. So we have 3-day weekends. And there's always an opportunity to learn and jump in and do something different. As Mayard said, you have a license to learn. So if you get into one field and you decide, well, that may not be the best field for me, you can always transfer and work in a different field. You also work with all different types of engineers. So you're working with computer scientists, you're working with electrical engineers. So you get to learn a lot, and there's a lot of growth opportunities. I love working at Lockheed.
Thank
And
you for all
I'm not just saying that because it's appraisal time.
No, I feel the same way. As I've told you all, I've recreated my career a number of times. And so there's a broad opportunity out there, not only in just aerospace, but in space. And if you're interested in helicopters, if you're interested in mission systems, missiles and fire controls, it's all those different opportunities are available. Let me know if I could do anything for you. I definitely would talk to you more about it if you like to, Anonymous. All right, with a spate of aircraft accidents, are there safety courses? Are the safety courses a requirement, and are refreshers mandated? Anyone want to take some of the aircraft accidents?
So I can speak to, I'm on the safety board for within my business unit at Collins.
Perfect.
And we don't have necessarily the courses that you take, but it's more of what we appreciate for safety and how we conduct our business with safety first, safety in mind. It's one of those things that you never compromise on, no matter how the schedule, how the pressure looks like. We always put safety first, because you think about it, that our products are on literally every airplane that's flying up, and space level or whatever it may look like. And you have family on there, you have friends on there, you have whatever it takes to and whatever it takes to get that flight going. You have to always put safety first. So I don't think we didn't I don't recall safety classes, but I do recall the ethics and the integrity of your designs, and making sure that you do not skip steps in order to speed up anything as far as that goes. So that's my take on the safety aspect of it.
Yeah, it's a good perspective.
There was also another question in the chat with regards to international students who may not be eligible to work in some of the defense companies. I don't know if you all want to take that, but I would also like to state that in the AIAA Diversity Working Group page, we have a whole seminar on that. And we're also looking to do another session on international students and employment in the aerospace industry.
I would also like to mention that a lot of times we limit aerospace to just the aerospace industry. But I know like when I worked at Lockheed, the wind tunnel right across the way, NASCAR used to bring their cars there. I mean, there are many, many different areas in which aerospace is applicable, even to skyscraper buildings. I mean, anything pertaining to airflow or even fluid flow when it comes to ships, things of that nature, that's also relevant.
Yeah, that's a great point. It's very diverse. Great point, Sheree. Another question, what does aerospace look like for a budding engineer from a school standpoint? I think I'm hearing that to say, yeah, Dr. Khan, did you have a thought there?
I mean, when I was in school, aerospace engineering was my passion. So I did my undergraduate in aerospace engineering, my master's in aerospace engineering, my PhD in aerospace engineering. I got my private license because I love to fly. So, it's an exciting field. And as we have been talking about, now the field is even more exciting from the point of view of those who are in high school, for example, because you have the opportunity to be out in space. I'm too old for that now. I'd love to go, but there are great opportunities for today's budding and aspiring aerospace engineers who are in high school right now. It's a field which is wide open. That's my thought. So yeah.
May I add just one quick statement on that? So Tuskegee is going to prepare you, to geek out with the best of them. I mean, we're all passionate about aerospace. It's going to, teach you how to understand lower Earth orbit hypersonic vehicle design. But at the same time, it's going to give you that balance where you can, you can ball and parlay and still geek out at the same time. So it's overall balance. And as an aspiring engineer, you will get that at Tuskegee, and you will get that, and the appreciation is just tremendous. If you have it inside you, that fire in your belly, to be aerospace, no matter what, you'll be great at it.
Absolutely. So at this point, I don't see any other questions here. So I'm gonna turn it over to Inaga Faley, the director of the NSBE Aerospace Special Interest Group and System Engineering Manager at the Northrop Grumman Corporation. Inaga, can you go ahead and give us some closing remarks?
Most definitely. So hello, everyone. I am really, really excited that we were able to have this conversation. One of the things I'm really passionate about is really talking about how are we helping drive things technically. And so as Ken just mentioned, I lead NSBE's Aerospace Special Interest Group, and we have a partnership with AIAA where we really look at how can we provide these opportunities to really not only enhance our understanding of what's happening in the marketplace, but also provide those experiential learning opportunities. So I saw there was a lot of questions from different students in terms of different programs that you can use. Also, how can you augment some of your learning opportunities to excel in industry? I definitely want to encourage you to check out the NSBE Aerospace SIG. I dropped the link in the chat. In terms of, we are an organization that supports the growth of an aerospace network globally. And so we have initiatives across the continent of Africa, across the Caribbean, where we're really trying to help people support people interested in growing in aerospace, and obviously within the US with a heavy focus on experiential learning. So this Black History Month, I just want to say this is an opportunity to continue to learn about all the great things that we're doing in history. I think it was amazing that we heard from some people who are trailblazing across industry. I love the focus on having technical mentors, and you have a number of people that you can reach out to for that. With that, thank you.
Thank you all.
Thank you very much.
Thank you.
Great job. Great job,
Thank you.
panel.
Thank you, everyone.